Hello everyone, we are here at the Vision Show in Stuttgart, and today, 5th of October, we'll have our epic product release from this very place, Messe Stuttgart, and we'll welcome to the stage 6 epic members that we chose for their new products and their relevancy to the photonic industry. And today, these 6 products are the metalenses of NIREOS Technologies, the laser diodes of Focuslight, the equipment of Palomar Technologies, the adaptive optics of PHASICS, and last, but definitely not least, the hyperspectral imaging cameras of NIREOS. Sign up online to participate in the meeting and join the Zoom room to ask your questions, your challenges, and your unmet needs that can be solved with these products.
Hello everyone, we are live. We are live from Messe Stuttgart. I arrived here this morning. I'm very excited. For those of you who don't know, the Vision Show in Stuttgart is a must-visit place if you want to know a bit about the state of the art of the machine vision industry. And from this location, I am running today the epic product release. As I said in the introduction, we have actually selected key companies in the sector that each have something really big to announce to the rest of the world. This is the news event of Epic, and we have put together a fantastic agenda of 6 new products for the photonic industry. First of all, we're going to talk about the next big thing. Quote me on that. The next big thing. Near-infrared meta-lenses, enabling 50,000 times thinner optics and their counterpart for 3D imaging and other applications. The next big thing. We're also going to talk to PHASICS because they develop metrology solutions, and today they want to actually test high CRA lenses with large field of view. We are also going to talk to Focuslight. Their acquisition of Limo put them together the best semiconductor lasers and micro optics. And today they're going to tell us how they're going to use it for 160 degrees field of view on LiDAR applications. We're also going to talk to DenseLight all the way from Singapore. They want to hear about the laser solutions for data centers that could make a difference for the transceiver industry. And in addition, we're going to go to San Diego, the US, because we want to talk to Palomar. They have a new die bonder that, because of their speed and reliability, will make a difference on the packaging of photonic integrated circuits and other optoelectronics. And definitely last but not least, we are going to go to Milano. And we're going to go to Milano to talk about one of the most exciting companies in the ecosystem today, the camera makers NIREOS, that today they're going to show us the Spider, a broadband amplifier photodetector with embedded analog to digital conversion. This is all going to happen on the next hour. We started on time. We are going to finish on time, all the way from Stuttgart, from the Vision Show. I want to welcome the first speaker today. And the next big thing in optics, micro optics, nano optics, you name it, meta lenses from NIREOS Technologies. Thank you very much for being with us today. The floor and the attention of everyone goes to Denmark, goes to NIREOS Technologies. Hello, I don't think we can hear you.
Sorry for the delay here. Thank you for the introduction. So NIREOS Technology have 3 different product categories. We have the diffractive optical elements, we have the meta optical elements, and the future displays. And today I will talk about the meta optics. So what is it that is exciting about meta optics? If you think about a classical imaging system, you typically have a lot of different refractive lenses, and you need many lenses in order to make a good imaging system. But with meta lenses, you can do with much fewer elements. It's even possible to make a camera with a single meta lens and a sensor. And this simplifies integration. It's also a very high thermal stability of the meta lenses compared to a refractive lens in glass. With meta lenses, you can also control the polarization, which opens up for making completely new functionalities. A meta lens can completely replace a fisheye lens So it's possible to make a flat optic that has a field of view that approaches 180 degrees. And all of these different type of metalenses is done on the same platform. So you can make focusing lenses, you can make diffusers and dot arrays with fan outs on the same technology platform. Here is an example where we have made a camera consisting of a single metal lens and a sensor. And then we compare it with a 6-piece system, so 6 refractive systems and a sensor. And you can see that the image quality is comparable. So it's quite amazing how much the metalenses can accomplish with a single surface. Right now, NILT is engaging with different customers for building modules, real camera modules. We're starting out with in the near infrared area at 940 nanometer. And it is the most simple cameras you can imagine. So it's one single lens and one single sensor. And these can be used for applications such as time of flight, structured light, and LiDAR. And the image here to the right is captured with such a camera. This is how the lens looks. So on one side, you have the aperture. And on the other side, you have the metalens structure. And then you have the sensor over here. And you can actually achieve in the design 99% relative illumination, meaning that you don't have dark corners as you typically have in refractive systems. In the prototyping phase, we are using electron beam lithography, and that enables us to be very flexible, making different designs and being quick to produce the prototypes in comparison to, for example, using deep UV for the exposure. The resolution is also extreme. With E-beam, you can have a spot size which is below 10 nanometers, and that is perfect for making these tiny structures that you need for the metalenses. It also makes it possible to not only make round shape, but freeform shapes. So it gives full flexibility in the design. NILT also has a very long experience in developing E-beam lithography, so it fits us perfectly. For the mass production, we are utilizing the precision in the E-beam for making nanoimprint masters. And then we preserve the accuracy that we have in the master when we replicate it with nanoimprint lithography into a resist layer. And after it's imprinted into the resist layer, we do a pattern transfer etch to transfer it into the silicon. And then we have replicated the metalenses. And this is a process that is highly scalable and that you can use in order to bring down the cost per element. And there are no constraints on material composition of the substrates or different coatings, for example, anti-reflective coatings and apertures. And it is possible to reach high efficiencies. So we have demonstrated more than 85%, and we are getting better and better, reaching higher and higher efficiencies. The way we work is that we start out with design, and then we have the build, which consists of the, for the prototyping phase, it's the E-beam process I recently described. And after the build, we do the structural analysis, looking in SEM, AFM, how the pillars come out, do statistical analysis. We also look at the optical performance, and we can completely link any deviations that we have in the manufacturing to the optical performance, which means that we understand how these different structural deviations affect the optical performance. So then we can make corrective actions, and we can tweak the design in order to improve efficiency or performance. And then we can spin this wheel very quickly for the prototyping phase. And we have a turnaround of around 6 weeks. And then for the mass production process, we make a master, a fully populated master that we replicate. So that is the end of my talk today.
Thank you very much. So I can tell you, this is the next big thing. It is the next big thing, and we want the whole EPIC industry, the 750 members of EPIC, to help you. So the first EPIC question comes to you. What can you do for them? What can they do for you?
Yes, so what we can do for them is we can design and produce optical components with advanced functions. So it can be fan outs, or it can be focusing lenses, and probably shrink the C height, or for example improve relative illumination or lower the F number. And for the second question, what they can do for us, so we are of course super interested in hearing what they need in terms of optical parameters.
Niklas, me too. I'm also interested in hearing what they need. So I brought to you one of the market leaders in automotive interested in metalenses, Motherson, Benjamin Samson. Welcome back to the EPIC show. Tell us, how do you see metalenses making a difference in automotive?
Nice to meet you. I think it can be really interesting because you can reduce the size of the lens set. And so it has a lot of application in the automotive. And my question would be, can we use this kind of system outside directly, or do we need to protect the lens from, I don't know, the wind, the dirt, and the water, the rain, and so on?
So typically the meta lens would, the lens structure would face the sensor, meaning that the other structure, which has the aperture, basically acts as a cover glass. So it's similar to just thinking of it as a cover glass in an optical module.
Benjamin, what makes me the most excited about this technology is that it's based on actual nanoimprint lithography. So these guys have made molds, have made masters with a technology that they will not reveal to you, but they managed to go to the nanometer resolution. And those masters can enable already today, volume production for automotive at affordable cost. That's why this is the next big thing. Niklas, thank you very much for releasing this product here. I want everyone in the industry, the 750 members of EPIC and the end users here, to contact you, because I want metalenses to be led by Europe. Thank you very much. And we continue with this fantastic product release show. We go now to our second presentation today. We go to a company that wants to do automated machining for large field of view and high CRA lens testing. We go to PHASICS, and with us we have Nolan Chang, who is the key account manager at PHASICS, and who is going to tell us how the other 750 members can benefit by the market leadership on testing based on wavefront sensors from PHASICS. The floor is yours.
Thank you for the introduction, Jose. So today I will present Kaleo-MTF, actually the new version of Kaleo-MTF, which is our automated machine for high CRA lens testing. But before that, I will go over with a couple words about PHASICS. So PHASICS is a French company that was established in 2003 for about 40 employees. And our main focus is designing, manufacturing, and supplying high-resolution wavefront measurement equipment from deep UV, so 190 nanometers, to 14 microns. All our products, our main products, are based on one technology that is called quadri-wave lateral shearing interferometry, which is a specific wavefront measurement technique. So here we have an example, actually a quick overview of the different products we have. So we start with the core of all our products, which is the wavefront sensor and the wavefront sensor technology. And we have two examples here. One is a visible wavefront sensor with high resolution, and another one that is specific to microscopy imaging, and that actually we can use a lot for meta-lens characterization. Just to give you an idea, our typical products, we can reach up to like 800 times 700 measurement points on the phase mount. To make a measurement, we also developed accessories to couple with the wavefront sensors, like we have here, which is a R-Cube illumination module, so that we can provide everything from the wavefront sensor to the source to have a high quality beam that can go through your optics, and then we use our sensors to analyze what is transmitted. We also have, and the next step, so more and more integration, a lot of different accessories to couple with these two elements, like we can see here, the wavefront sensor, the RQ module, optomechanics, and then different optics to shape typically the beam that goes out of the RQ. That can be converging, diverging, or really large and high quality collimated beam. And if you want to go to even more integration, we have turnkey solutions, so completely automatic machines, like here, Kaleo multi-wave, which is an interferometer-like system. So it is used like a piezo. It can be used with the accessories of a piezo interferometer, but it has the versatility of wavefront sensors. So in terms of wavelengths, so you can have up to 8 different wavelengths inside, and you can also have large dynamic range. That is typically one of the specificities of the wavefront sensors. And what I will focus on today is actually Kaleo-MTF, which looks like that, and also like that in total, in full size. So the idea of Kaleo-MTF is to characterize objective lenses, so imaging optics automatically. So what kind of optics do we measure? So they're actually quite small, and you can see the actual scale here. So it can be either smartphone lenses, automotive lenses for autonomous cars. It can also be meta-lenses or more specific lenses. So the idea is really for us to measure high-end and high-performance lenses, because typically what we have now, and as it was mentioned just a few minutes ago, the devices are going really smaller, and smaller means that you have more CRA, so higher angles to aim for the edges of the sensor. You have high NA for more resolution and more pixels to have better images. You have a wider field of view to see more with less devices. And something that also comes with that, and that has been quite a headache for the recent developments, is we have nonlinear CRA evolution, distortion, etc. across the field that can be hard to measure. And we really focused our development on these really hard to measure lenses. But what do we do exactly for these lenses? So we measure, of course, for up to 8 different wavelengths from in the visible and the near infrared, the different parameters that are, of course, the OPD, which is directly the wavefront information, the optical aberrations, the MTF, which is the imaging quality, some geometric parameters like EFL, F number, field curvature, etc. And the idea of the whole system is to give as much information as you can with a single machine and a single measurement. So the specificities of our machine is really to have a fast and fully automated measurement process, a quick setup with no alignment. You simply need to place the sample inside and you will have all the measurement. You can customize the measurement sequence. You can choose the wavelengths, the angles, the azimuths that you want. All the results are basically in wavefront, and we can change the plane where we analyze the wavefront, so you can really compare to the design that you have. And we, of course, have accurate and reproducible measurements. So as I mentioned, we aim for really high-end and high-performance lenses. So these are typically used in the automotive, smartphone, augmented and virtual reality. We also aim later on for drone and surveillance applications. So to end this presentation, of course, if you have any questions, don't hesitate. I'll be glad to answer it. We also plan to have a demonstration of Kaleo-MTF that will be coming in the form of a webinar, so don't hesitate to contact us by email or through our website to register.
Thank you very much. Contact at PHASICS.fr. Contact them there. This is one of the key companies to watch. I have some questions for you, but you get the first question for me, which is the epic question. What can you do for them, and what can they do for you?
So, of course, for the other members, we would be glad to collaborate and to actually discover what kind of hard challenges they have and what kind of metrology issues they can encounter. And for us, as we are developing new solutions all the time, we'd be glad to have some samples or some maybe things that can be shared and for which they would like to know if it's measurable, because that's actually quite a common issue in innovation, that you develop things that you cannot measure and that you cannot control. And we're also working on that, on how to measure these particular things.
Nolan, for you, we brought one of the key companies in developing gratings for spectroscopy. This company is called Photonics. Morten Hansson, welcome to the meeting.
Thank you.
Morten, when it comes to metrology, what are the challenges to validate the different gratings that you supply to the spectroscopy manufacturers?
See, Jose, now you are hitting me on a bad spot, because the grading business is not with my area of responsibility. And since I only joined Ipsen for a few months, my insights into the gradings is not too big. But what I do know is that our technology for gratings is very unique. And what it is that we are capable of is making sure that all of the gratings are the same every time, and that we can actually qualify them afterwards. So measuring how good they actually are, the actual grading, and how clean they are. So I think that's my best answer that I can give you right now.
But you have to introduce, Morten, you have to introduce Nolan to the right person on the grading manufacturing at Ipsen, because there is a great room for cooperation. Nolan,
Yes.
Two more things for you. We brought two automotive rock stars of the industry that wants to characterize the optics for automotive, because I know it's an important market for you. The first one is Moderson Innovation. Benjamin, thank you very much for joining again. What's on your mind?
Yeah, I've seen few products like this, and I would say that most of the time they try to integrate this product in a production line. And I would like to know if this is something you can do also, or do you only target development phase of a product?
So actually, we have quite a history with the integration and production lines. So of course, the product that I just presented today was more of an R&D product, because it's all closed and you cannot measure 1,000 lenses per second. But the idea is that we can integrate the core of the technology and use our actual expertise to adapt to specific production lines, like we did in the past in automotive industry, actually in metallurgy industry, and also in semiconductor industry. So these are all concrete examples that we could discuss if you're interested, but this is also part of our experience.
The second one is a tier 1 supplier from Europe, from Germany, called Norden Cars and Concepts, LED lighting solutions for automotive. Alexander, welcome to the show. What's on your mind?
Hey, Jose, nice to see you back again. Yes, on my mind is the question which I posted in the chat. Basically, is this technology applicable to do a dye trial analysis? So you have some automotive optic lenses made of glass or PMMA with micro-optic structure, and we wonder if it's possible to scan it like with a CT scan, what we usually actually use for it, which is quite expensive if you do it quite often, and whether it's possible to get some CAD data out of it and match it with what we have in our design.
So what we output is more the optical performances. So when I was referring to design, it's more the optics design. However, depending on the optics that you want to characterize and the complexity they have, it's possible to draw maybe a map of defects and link it to optical performances. This is also something that we did in the past. But of course, if you have a lot of different components, the complexity is quite exponential. So I cannot say that this is easy to do. But we have also worked with wafer lenses testing for this kind of application. That was quite similar when you want to retrofit with the process, given the different output that you have from the machine.
Thank you very much, Nolan, and thank you for the two automotive companies that came here to scout technology. It's great to have you here. We continue with the program, and now we go to one of these companies that gives me goosebumps, because when a laser supplier and a micro-optic manufacturer join forces, something great happens, and something great is happening on lasers for LiDAR, Focuslight Technologies. Simon Drops, thank you very much for being with us today. The floor and the attention of everyone goes to your lasers and your micro-optics. So your Focuslight and Limo goes to you.
Thank you very much for the nice introduction. So
we can now share your screen and we can start the presentation.
I hope you can see it already. If not, please let me know.
Not yet.
Not
This
yet.
is Zoom. As you click on share the screen, then you have to select the window that you want to share with the universe.
I did, but I didn't press share afterwards again. So that was my my failure. So sorry for the delay. Yeah, and welcome to my presentation. Now it's moving. Okay. Today I want to talk about long focal length FACs and wide angle diffusers up to 160 degree for LiDAR applications. And I'm Simon Droves, and I'm product line manager at the laser optics business unit of Focuslight Technologies. Since there is always a little bit of confusion what's LIMO doing in the structure or how the company is structured, I would like to briefly give an overview about the structure, since we merged, we joined, and something new was created. So Focuslight Technology is a group, and the laser optics business unit is one part of it. And of course, it fits very well to a diode laser company, since then you have everything under one hood to get the best or very good lasers. I don't want to offend other laser companies. The laser optics business unit does have two locations: Dortmund, that's LIMO, where I'm based. We do the wafer level production of optics, and Dongguan, where we do the coating and the dicing of the wafers into single optics. We do a lot of things. We do photon generation, photon control, photonic application solutions. The core of the laser business unit is photon control. We do simulation and production of high precision optics. And we do this with our unique high precision 2D freeform process, which allows us to put acylindrical and cylindrical structures into different materials. The production is wafer based, which means we can produce on wafers up to 300 times 300 millimeters, which enables for high volume at low cost. Both wafers sites are individually addressable, which means you can yield monolithic solutions. For example, on the right side, you can see a single piece of optic, which allows a half bar to be coupled directly into a fiber instead of using an FAC, an SAC, and one or two lenses to couple it into a fiber. So that's one point, which is also very interesting for laser manufacturer, which we are as well. Our materials that we can use are ranging from the UV to the mid-infrared. So we can supply the whole range. We can process calcium fluoride, fused silica, as well as high index materials and silicon. We do offer FACs, SACs, wide angle diffusers, and a lot of different other optics. You have a standard portfolio to pick from, as well as customized solutions. We offer long focal FACs for automotive and LiDAR applications. So over here, you can see two examples of our lenses. The FAC 3000 with a focal length of 3 millimeters, and the FAC 7700 with an effective focal length of 7.7 millimeters. The residual divergence is always depending on what kind of source you are using. So I stated over here just the residual divergences you get from a common nanostack, as well as some products that are fitting to, depending on the length, to the 4-channel or to an 8-channel nanostack, which is commonly used in automotive LiDAR applications. But for such applications, you can also use wide angle diffusers. So we do offer diffusers which are spanning lines, and two of them can span a rectangular field of view. And this field can be asymmetric or symmetric, the power inside the field. So we have 100% control on the power where it has to be for our customers. I want to show you some examples. So over here, we see one of our standard diffusers with a high angle with 120 degrees, and some other well-established companies are struggling at the very high angles where we excel. So over here, you can see a profile of a Focuslight diffuser in comparison to some other diffusers. And besides of the 120 degree, we also recently, we are recently publishing the 160 degree. So we can create every field of view up to 160 degree. You can get top hat profiles, bedwing profiles, asymmetric shapes of profiles. Depending on your use case, we can design the exact diffuser you need and the field of view you need. So that was my presentation. If you have questions, don't hesitate to ask. I'm very happy to answer them now or later.
As I always say, if you want to get in touch with any of the participants today, all you have to do is send me an email and I will make the introduction. Simon, you know the drill. 750 companies just heard what you have to say. What can you do for them? What can they do for you?
So since we are a big group, we can do a lot. So I have to focus a little bit on the laser optics business unit, or maybe a little bit the automotive business unit, since they are connected in this field towards each other. What we can do, we can help our customers to get the exact right optic that they need. So we want to collaborate on solutions, not only on optics, but we want to create solutions for our customers, which are fitting to their use case. And this can be that we provide the product together with the automotive business unit, or that we provide the exact optics that are needed for spanning the right field of view, asymmetric shapes, or to get the right lenses for your use case. What they can do for us would be the next one.
Yes.
So we are always interested in, for example, to improve always, to be at the top always on our metrology capabilities. So I was hearing already with interest PHASICS. So I probably will contact you afterwards. I want to reach out to you, but I already saw also some other interesting, possible collaborations, since there are other companies around which are developing right now new capabilities, new possibilities in creating optics, like Glasomer. So
thank you very much, because I want to do that exactly. So PHASICS, we also have Imagine Optic, we have Mountain Photonics. They can help you with the metrology challenges, and Nolan is going to contact you offline. But Simon, we had a lot of meetings on LiDAR for automotive, and the big challenge there very often was the material used for the optics, for the micro optics. Dorothea Helmer from Glasomer, what do you do and how can you help Focuslight?
So we're experts in structuring fused silica, and we do injection molding of fused silica. So basically any shape that you can get a polymer, a plastic lens today, we can make in glass basically. And obviously I follow LIMO because they have some very interesting structures. And Simon, thank you for the very nice presentation. So I would have a question concerning what you just presented, so or a little bit more than that, because you also make DOEs, right, with your wafer-based technologies at LIMO.
So we are developing capabilities in all directions in the optic market. We are mainly doing refractive optics. So that's what we are excellent.
So I would be interested in what's kind of the based on the etching process, is there like a limitation to the height of the lens? So like the middle and the highest part of the lens?
So since we are not doing an etching process, but a different process, we are not as limited as other companies concerning the sex or the difference. So we can go very deep in there without increasing the processing time too much.
Okay, so can you give an idea on how you do it? Is it like first lasering and then etching, or no etching at all?
It's a simultaneously structuring process. So the wafer is structured at the same time, all the elements, and that's all I can say about this.
Glassover is one of the key companies in our network. For the injection molding companies, you're looking for glass shaping at room temperature. This is the company to watch. This is one of the ones to watch. Dorothea, it's so great to have you in our network. Simon,
thank you.
Another thing, when it comes to volume production of micro-optics and lasers, there is something big happening in EPIC, and that's Icon Photonics, all the way from France. Charles Guller, thank you very much for joining. You have developed a process for wafer level optics being packaged in semiconductor diodes. How can you help Simon?
Yeah, thanks a lot, Jose, for the introduction, and thanks everyone for this meeting. That's very nice. So yeah, as you said, we are working on coupling solutions directly at the wafer level. So it's based on a polymer material that we have the capability to structure at a wafer level, and we go beyond that also by integrating some advanced packaging solution, for example, fiber insertion already at the wafer level. And so yeah, that could be interesting to discuss with you, Simon, about all that. And for you, I will have a small question, perhaps a classical one. What's the minimal dimension that you can reach concerning your micro optics at a wafer level? I'm talking about the density over the wafer here. So
is the question related to the single optic or more to the single element?
I'm talking here about the micro optics on a surface. So I guess at the wafer level also. Okay. What's the minimum size that you can reach?
So one of our typical sizes are below 3 times 1 millimeter concerning an optic that we are providing. But we can go also below that. And concerning the structure on those optic, it can be way below that. So we can even further below. At some point, it gets a handling problem if you want to have very tiny lenses, but we have experience with it.
Simon, thank you very much for being a success story on bringing semiconductor laser to automotive applications, having fully automotive qualified process. Thank you very much. You're going to be in contact with Nolan. They want to get in touch with you. It's been great, but we continue. We continue with the fourth presentation today. And this one is something big. DenseLight, the company that have a hybrid platform for making semiconductor lasers, have a new laser product line targeting the data center applications. And to present it, we have nothing less than the Vice President of Sales and Marketing and personal friend of mine, Soma Sankaran. Soma, thank you very much for being with us. This is one exciting new development in your network. We are very happy that you chose the EPIC platform for launching it to the public. The floor is yours.
Hey, thank you, Jose. Thank you for the introduction. Good evening, everyone. And so, as Jose mentioned, DenseLight is based out of Singapore. And what I'd like to do today is essentially to introduce a new family of lasers that we have introduced for the data center market. And time permitting, I would also like to talk about a series of broadband light sources that we have introduced for the spectroscopy market. I hope everyone can see my screen. Okay. So, yeah. So let me first tell you a little bit about DenseLight. We are a vertically based, integrated company based in Singapore. And essentially, we have our own indium phosphide wafer fab. So that kind of differentiates us from many of the other players in the market. We design our own chips. We fabricate them in the location in Singapore. So you can see the little building over there. We do have testing and limited packaging facilities there. And for most of our packaging, we subcontract it out. We do have both indium phosphide and gallium arsenide capability. But these days, most of the focus, given the markets that we focus on, is indium phosphide. And one of the key things that we have developed is really the indium phosphide bonding of indium phosphide light sources to silicon photonic-based engines. We have a number of, we have over 100 people. We have 150 customers across the globe. We are homegrown, meaning we started in Singapore almost 21 years ago. So the markets that we focus in, essentially we have two markets. First is the sensing market, and some of the speakers here talked about automotive LiDAR, which we are in which we actually are focused in the 1550 FMC W LiDAR space with our SOA and gain chips. And apart from that, we do have broadband light sources for the IoT test and measurement market, as well as fiber optic gyros. We have narrow line with lasers and with built-in amplifiers up to 200 milliwatts for the wind LiDAR market, and also a range of DFB lasers. About 3 years ago, we started designing and building components for the datacom market into the 5G, as well as the intra-DCI market for tunable lasers in the coherent space. And we're working with customers, some customers for the 400G space. And what I'd like to talk about today is really a couple of products that, especially one product in the 400G space. Oops, I skipped a bit ahead. Very quickly, as I said, we had capability to design and grow our own wafers, and we do end-to-end manufacturing. So we do have our own epi reactors. We do have the ability to fabricate our own device, cleave, coat, and test, as well as to burn in. So essentially what I'd like to do today is to first, I'll skip the first slide and go on to this slide. The first product that I'd like to introduce is really the 70 milliwatt 75C continuous wave DFB laser. So what's interesting about this laser is that it's a BH, buried heterojunction, and it's non-aluminum containing. The reason it's non-aluminum containing is that we've had several customers come to us and say, they wanted to have high temperature performance, but without aluminum. And the feedback is that aluminum tends to degrade the material performance over long periods. So we had some key customers where we engaged with, we designed and fabricated these devices in our fab in Singapore. We have all 4 CWDM wavelengths. And the key thing about this is that we actually, this chip is customizable to fit into silicon photonics platform. In fact, some time back, we actually announced a partnership with AMF, one of the silicon foundries, where we are developing a solution, a rule of engagement, if you will, where if a customer wants to do a specific engine on a silicon photonics platform, they could come to us with a light source and we would be able to customize the design very easily. We do have non-hermetic coating options available. We have reliability data up to 2K hours, which we can share with you if you're interested, and we are able to sample now. The key application is really data center interconnects, and specifically, we want to start off with DR4 500-meter application. So if any customers out there are designing this, we'd be very interested in talking to you. The other product that I'd like to talk about is really a low DOP sled. So we've had a number of customers in spectroscopy come and tell us that they already do buy our low DOP systems. In fact, some of our customers are on this call, but these are systems that are built with which we have the sled and are built with some passive optics. But what we've done is we've come up with a sled that actually outputs a very low PER performance light source. It's again designed here in Singapore. You don't need additional passive components to confirm the degree of polarization, as well as of course, it gives you lower system cost because you reduce or you don't have additional components. And our focus really is in FBG sensing. So thank you for listening. And these are the two products that I wanted to really talk about today. My contact is over here, and you'd be able to, if you take a snapshot, you can send me an email easily. And I guess, Jose, you want me to answer your epic questions?
Yeah, but let me ask, because I had to ask. So 750 companies, all European, but also some of them from Singapore, as you see, and also from US, from China, everywhere. But we focus on Europe, the European industry. And European industry wants to help you. What can you do for them? What can they do for you?
Yeah, thank you for that. Yes. Of course, what we could do for you is bring some of the technology that we have developed. So apart from the laser, we definitely have light sources for tunable lasers, especially for 1550 nanometer automotive LiDAR, as well as coherent communication. So we'd be able to bring this to your table, help you customize these if you want, because we have our own wafer fab. That's definitely what we can do for the customers on this call, as well as in all the EPIC members. And what can you do for us? Obviously, this is a platform for collaboration, and the more we collaborate, the better chances we have of bringing unique solutions to the table. So, and I know that in Europe, there's a big silicon photonics ecosystem that supports the delivery of optical engines, and we'd be happy to connect with customers with whom we can partner to deliver solutions to the market in Europe.
So the photonic industry is very happy to have a hybrid integration platform that they work from DenseLight, indium phosphide, and silicon photonics. It's fantastic to have it, but we are desperate to have a C-band tunable laser, and if possible, a C+L band tunable laser on a semiconductor platform at an affordable cost. Is that something in your mind, something that you can help us with? That's an unmet need, a big one.
Absolutely. As you know, Jose, I participated in the LiDAR call. We're already talking to some of the folks over there. Yes, we do have the individual components for a C-band laser. We are already talking to one of our Silicon Foundry partners to actually integrate that into a LiDAR solution. But yes, we do. Obviously, we seek the right partners or right end customers whom we can engage with, so that these ideas can be put into products.
Indium phosphide over silicon photonics is the revolutionized material system for photonic integration. Thank you so much, Sankaran, for representing DenseLight today at this meeting. And we continue with the meeting. We continue. So far, we spotted lots of great room for cooperation from DenseLight. We go to the next presentation. We go to Palomar Technologies. We go to San Diego, California, to hear about this new die bonder that Soma from DenseLight can use for the laser technologies. Presenting Palomar Technologies' new die bonder is Kyle Schaefer. Thank you very much for being with us. The floor and the attention of everyone goes to beautiful San Diego, California, goes to Kyle.
Thank you. So yeah, I'm going to just give a quick overview of Palomar Technologies as a whole, and then jump into our new die bonder, the 3880-2. So at Palomar Technologies, we supply not only packaging equipment, which I'll go over in a second, but we also have our innovation centers positioned globally to help EPIC members essentially work through process development or low volume manufacturing. And as I mentioned, we have a global presence. We have some main facilities in Germany, in the UK, in San Diego, and in Singapore. As far as what specifically we offer at Palomar Technologies, we offer die attach machines, wire bonding machines, and vacuum reflow systems. Just talking about the innovation centers briefly, what we can do there is we can work with customers to prototype or work through process development of any new products that they have. And we can kind of get them a jump start into their new products. So our first innovation center we have is in the US, over here in San Diego. We also have one, as I mentioned, in Singapore. We have testing and we have manufacturing equipment there, so we can both build assemblies and test them. We have another innovation center in the UK at the other EPIC. And then we also have a presence in the Fraunhofer Institute, where we can also do some low volume manufacturing and prototyping. Now going to the new product that we released just a couple weeks ago, it's our next iteration of our die bonder. It is the 3880-2. It is able to do epoxy die bonding, eutectic die bonding, flip chip, and really its key quality that I would say is that it is highly flexible and very quick to program and get up and running. So ideally suited for customers who are looking to have a machine for R&D, but it's also scalable to go to autonomous production and can be outfitted with conveyors and magazine handlers for full-scale manufacturing. To kind of show some of the breadth of the flexibility of the system, here's some mock-ups of our work envelope. So you can fill it with, general stages, maybe a die ejector and a conveyor, tape and reel feeder. You can have pulse heated stages or custom UV stages. We also, can integrate things such as an atmospheric plasma cleaning pen. So you can, plasma clean the bottom side of die before you go ahead and bond with them. We have dispense capabilities, pin transfer for epoxy stamping. We have, other variations of die ejectors, so you can go to, larger volumes, a heated conveyor, flippers for flipping die that are presented, so that way you can do flip chip. And we can also, do much smaller layouts if you don't need every piece of equipment. So essentially it's customizable to whatever a customer may need for their applications and whatever types of processing equipment that they need for their application. And then once you design or set up your workspace for what you need, you can use it for multiple assemblies if you need to. So for instance, here's a particular setup, and it can be used for various different assemblies. So I'm just going to kind of cycle through some, and you can see the different pieces of equipment that are lighting up for various applications. So definitely flexibility is kind of the key focus for our die bonding technology, because we want to be there for not just your first application, but every application after that, right? And to kind of show a little bit more in terms of the scalability, this is just a short little clip showing the bonder in action and just how it can continue to scale up over time. You can start with a relatively low investment, add in some automation such as a conveyor, and then go to die ejectors and continue going for whatever you need and for whatever capabilities. Now to kind of jump into the newest technology that we brought into this machine is our tool changer. So we have for a long time used a tool turret which can hold 8 vacuum pick tools, which are there for manipulating components. But now we have the ability to store extra tools on the work envelope, load them into the tool turret, and move on. And this is all automated through the build process, so it can continue, autonomously building. Once you switch over to a different set of products, it can switch out the tools that are being used for tools that are needed for that application. We also have the new high force position, which can go up to 5 kilograms, which is useful for thermocompression bonding or just for any type of epoxy bonding with large components that need higher force. It's also a lot more robust and repeatable of a position. To kind of go over just a couple other options to kind of round out the machine. There's a lot to talk about, but I'm just trying to hit the high points. We offer various dispensing capabilities, jetting dispense, auger pump, time pressure, specialized dispensers that can dispense all the way down to 150 micron diameter dots. We also offer diverse UV capabilities, custom UV stages, a large flood cure UV that can move over to a conveyor or to another area into the workspace, UV on the bond head. We also offer heating solutions, so a localized pulse heated tool, heated conveyor, a precision pulse heat stage, and a standard pulse heat stage. And then I mentioned as well the custom option integrations such as the plasma cleaning solution. And that's everything. So, well, that's not everything, but that's as much as I can cover in 5 minutes.
Thank you very much. Coming all the way from El Camino Real in San Diego, California. Thank you very much for being with us today. You know the drill. 750 companies, many of them need packaging equipment. What can you do for them? What can they do for you?
Definitely. So what we can do for the EPIC members is really come to our innovation centers. If you have a new package design or something that you need prototyped, any form of heterogeneous integration, we can work with you, develop that, provide testing capabilities, just kind of help you get through that early product development.
I recommend sorry, go ahead.
Oh, no problem. I was just going to say, what they can do for me is essentially share some of their newer technologies with us, so that way we can have a better understanding of what's out there, what equipment is going to be needed in the future, and so we can position ourselves to have the equipment ready for any type of processing capabilities that will be coming up. So it's always good mutual benefit.
I recommend everyone to go to Torbay in the UK, not only because it's beautiful, also because the Center of Excellence of Palomar Technologies is at the EPIC Center, at the EPIC building. And there they are supporting companies. They're supporting companies that can actually use their equipment already today. And of course, if it works, they can actually have the help to have the equipment at their facilities. One company very interested in your technology is the embedded system company Topic, and is represented here all the way from Eindhoven by Dirk de Man. Dirk, goedemiddag. What's on your mind?
Goedemiddag. Hello, Carl. Hello, Jose. I was fascinated about your speech, Carl. Thank you so much for sharing it with us. I'm a dreamer, they say, and I always like to look, when I see these systems, 5 years ahead. So if you look at your operation system and your ideas on that, what are your thoughts and how far are you guys with stuff like artificial intelligence, machine learning, deep learning, computer vision, and stuff like that?
Definitely. So we have, pretty robust computer vision system already, but in the future, that may be something that we look into as far as machine learning for our control systems. Naturally, you want to go as fast as possible so you can get the most throughput, but that's always, a struggle of trying to maintain that the accuracy and precision and high throughput. And, machine learning or AI can definitely, lend a hand to some of those more complex control systems that aren't going to be perfect for every situation. So definitely something that, we have been thinking about and looking into, but like you mentioned, it's in the future and it's something that may come at some point.
Yeah, and the future starts today, right? So I would love to get in touch with you and share some ideas about that, because
definitely
we've got some experience on some of these projects, so it could be interesting to have a chat.
We are talking about one of the key companies in embedded electronic systems. This is a key opening, and in Eindhoven, they are connected to some of the key lithography and other companies alike. I'm not going to mention the names that can actually be in collaboration with Palomar. Dirk, thank you all. Thank you very much for being with us. And like every fantastic show has a beginning, it also has an end, but we save one of the best for the last. We go to Milano to get to know a young company that is developing fantastic camera systems. We talked to them about hyperspectral imaging, but now we're going to talk to them about photodetectors coupled to ADC converters. We want to understand why and how we can help them. The floor and the attention of everyone goes to Milano, goes to NIREOS. Grazie mille.
Grazie, Jose, and thank you for your effervescent hosting of this great event. So, we're NIREOS, we're in Milan in Italy, and we're a fairly young company. As you can see, we were founded in May 2018, and our sort of core knowledge so far has been based around interferometric measurement of spectra, or interferometry, which is a counterintuitive way to measure the spectrum of light, because most people think of a grating or a prism, but those people that know Fourier transform IR spectroscopy know that you can also do it with an interferometer, and our core products have shown that we're able to do that in the visible. So as you can see below, we have a Gemini interferometer and a hyperspectral camera, which really goes against what some people know about hyperspectral cameras as well, being that it takes full images at a single time and gives you complete spectral information. Though today I'm introducing a new product which we sort of stumbled across, and it seems kind of small, but we think it could be really useful. So when we were supplying people with this Gemini interferometer, a lot of the time they could just drop it in to their existing systems and provide themselves with spectral resolution where they previously didn't have it. Other people needed to measure the light themselves, and so they would supply their own measurement tools, be it photodiodes, amplifiers, digitization systems, and things like that. And so while we were in the course of actually developing our next product, we decided that we weren't happy with the existing solutions for that, and we put together our own package, which is able to, how can I go to the next slide? There we go. It's a photodetector, it's broadband, and it really is initially coupled to Gemini. It was designed to be used for these sort of measurements, but we think it's so useful in such a tidy package that we really wanted to just see if other people were interested in using it as well. So it's a photodetector, it's very broadband, it's amplified, and it's completely embedded with a DAC, or an analog to digital converter. So we call it Spider. The spectral range is really broad, from 320 to 1700 nanometers, because it's using a sandwich silicon and in-gas photodiode. And then coupled to that is a pair of transimpedance amplifiers that we developed ourselves, which are incredibly low noise and mean that we can really crank the gain up all the way to 130 decibels. And then in order to take advantage of this really phenomenal detection path, we have an incredibly high resolution DAC, or a ADC, I should say, analog to digital converter. So it's 24-bit compared to 16-bit, which would be the norm for nearly every other system that I've previously used in research labs over the last decade. So people that use these sort of systems will be used to measuring things on a scale from 1 to 65,000, more or less. And whereas with a 24-bit system like this, we're measuring from 1 to 16 million. It gives a lot more resolution. Hasn't been needed in the past because amplifiers and photodiodes weren't really up to it. But at the moment, we've found that all of these things are hitting the stride, and we put them together at one. It's also a super high rate DAC, so which that means it gives us some other advantages. So this is just the product as it is, the Spider. It's going to be coming with a bunch of various software packages that people can use depending on what their application is, but it's really simple. Everything's programmable over USB. It's got a reasonable bandwidth and analog outputs in case you want to use other instruments with it. It can be programmed. It has digital in and outputs so that you can synchronize other instruments to the Spider, or Spider to other instruments, and even buttons and a small display on the back, so you don't need to use a computer if you don't want to. So I just wanted to give like a little example of the way in which it might be used. As a very simple example, we want to measure some photoluminescence from a luminescent dye, in this case rhodamine. And so you plonk down the dye with an illumination source in front of Gemini, light goes through the Gemini, it is interfered with itself, and then put on the Spider. Contrary to what this photo may look like, the laser is not intense enough to rip through space and time. It's a fairly weak amount of light that we're measuring here, but we're able to recover a very accurate spectrum from the rhodamine. And in fact, it's to really show it, I'm going to compare to the solution we would have used before, which is like a commercially available amplified photodetector with a 16-bit DAC. And here you can see in real time the two instruments running, Spider on top, and the increased noise level, well, decreased noise level and increased sensitivity really makes for us an incredible difference in the data we're able to measure. So you see the result there. Furthermore, because it's so broadband, we can measure in a single measurement a huge spectrum. So this is just the fluorescent lights in the room that I'm sitting in right now. And in one measurement, we get all the way across 3 octaves of wavelength from 400 to 1700 nanometers without any of the problems you might have from a grading spectrometer, like second order diffraction or having to use a series of filters. It's super convenient, it's super simple to use, and we're hoping that people can find a use for it. So thanks very much. And back to Jose.
Thank you very much. We have here a photodiode. We have here a photodiode with the electronics, and you are looking for strategic partnerships for it to be implemented in systems. 750 companies, they want to help you. Which are your target companies for them to connect with you? What can you do for them? What can they do for you?
Yeah, well, really, we developed this for the specific application in mind, you know, and it's clear to me how it's good for that application, but I'm sure it's just such a useful little tool that isn't out there. So basically anyone that wants to measure light accurately and save themselves the time of developing this really simple but elegant little product, those are the people I'm looking for, people that that would make use of this.
Very good. At the end of the day, one thing that for me I'm quite amazed about is that NIREOS, in the past we have talked to you about the camera manufacturing business, where you have the Gemini there. We also have talked to you about the shortwave infrared area, the hyperspectral. This is one of your secrets in the sauce. This the way that you actually make the accurate detection of light, and you want to cooperate with other camera manufacturers. I believe that many of them are going to be in touch with you after this presentation, because I can tell you to everyone I have talked to NIREOS, I endorse this product. This is something really, really big, and that has made a difference in the way that NIREOS is now one of the most exciting companies as a camera manufacturer. Thank you very much, Alex, for thinking out of the box and releasing a product that can help other companies make better cameras. And to all of you, it is 6 minutes past 5. I'm only 6 minutes out of time, and with that, I am really happy. Please keep in mind, travel. We need to get the industry moving. If you wait at home until other people start traveling, nobody's going to travel. Until the next time, this was Jose Pozo here with a fantastic set of companies that are today making a difference in the photonic industry. And that concludes the public part of today's meeting. If you are in our Zoom room, our informal private discussion is about to start. I call it virtual drinks with friends. And we all know